is 2, negative 4. 2 is 1, negative 6. 3 is 3 over 2 and 1. 4 is 3 and 5 over 2. 5 is 2 and negative 3 over 2. And 6 is 6 and negative 2. You're in that seat right there. And we're grading homework, so I'll take yours. Yes?
Is 4 the fraction of what?
On 4, the fraction is negative. Okay, so anybody sitting in here have any questions? Does anybody online have any questions? James, if you gave me the paper yesterday, it's already in the grade book. It's already been graded and put in the grade book. So if you turned the paper into me yesterday, I've already got it in the grade book. We're done. If you did not, you need to type your score in the chat bar. For those of you that are remote, take pictures of it and send it to me. But I want to see that it's done today because today's the due date. And I want to get in the habit of getting things turned in on time. So stand by while we get ready to move on to the lesson. For you guys, this was out of 12, by the way, everybody. So tell me what you got and pass them up and yours. Think you can do it? Okay, why not? Okay, those are mandatory. From now on, you have to be on the Google Meet, and even if you were on the Google Meet, it's on campus. Thank you. Welcome back. Huh? I can fix it for you. Don't worry about it. All right, so let's go ahead and put our phones away. I'm taking a piece of paper. We're going to do some notes. Okay, thank you for the scores reporting. All right, so today's lesson, we're getting ready to get started. It's going to be simplifying radicals because we did the quadratic formula, and I told people, like if you got a number under the radical that wasn't a perfect square, I told everybody to stop. I just said stop. Right. Well, now I'm going to show you how to simplify those so that we can keep going and make kind of a final answer. So that's today's lesson to compare for complex numbers. And then we'll practice more with quadratic formula with all of it put together. Okay, so we're not quite done with it. I want to make sure that this is something that we can do. So that's the drill. Give these paper out and take notes. So that's what we're going to do. I got a six question assignment today. Pretty short lesson, so you should be able to get it done and turned in. So you guys will get it done in class and be able to turn it in, so you won't have to worry about it tomorrow when we grade. All right, so this lesson is simplifying radicals. Which is what we have in the quadratic formula. You know, the square root of something, that's a radical. All right. And when you got perfect squares, like this one, I had you go ahead and simplify that because the square root of 9 is 3. So we went ahead and simplified those. But on on all of the assignments, when you got something that looked like this, I told you to stop. I told you I'd get to it now. So now I'm going to show you how to further simplify this, and I don't mean with decimal, because I don't want decimals here. What I'm going to do is I'm going to break this down into its factors. Factors are the numbers we multiply to get something. So the factors of 20 are 1 and 20. We could do 2 and 10, or we could do 4 and 5. I'm going to pick 4 and 5 because 4 is a perfect square, and that's what I'm looking for. I'm looking for a number that goes into that that's a perfect square. So we're going to do square root of 4 times the square root of 5. Because 4 times 5 is 20. So this is the same thing as this. So now I can simplify because the square root of 4 is 2. 5 is prime, so it's going to stay under the radical just as it's written. So it's going to give me the answer 2 square root 5. And we're going to keep doing this, okay? We keep doing this in our problems until we can't do it anymore, until the number under the radical is prime, or until its factors are both prime. And I'll show you an example of that in just a second. Okay, so everybody kind of understand what we're doing here? All right. So here's another example. Let's do the square root of 27. And if anybody online has any questions, unmute your mic and ask. I've got the speaker turned up so I can hear you. I'm not looking at my computer so I can't see the chat bar. So the factors of 27, oh, hang on, these guys are coming back in. Good, welcome back. We just started. So the factors of 27 are 1 and 27 or 9 and 3. So this, the square root of 27, can be rewritten as the square root of 9 times the square root of 3. Well, the square root of 9 is 3. So I'm going to get rid of that, put 3. The 3 under this radical is prime, so I have to leave it. So my answer here is going to be 3 square root 3. That's the final answer. That's how you simplify a radical that's not a perfect square. Here's another one. So I'm going to start with something that I know. And I know that 80 can be broken down into 4 and 20. Because 4 times 20 is 80. So I'm going to do the square root of 4 times the square root of 20. Well, the square root of 4 is 2. So that leaves me 2 square root 20. Okay, but this isn't the final answer. Because this number 20 has a square term. Has a perfect squared term. Okay, its factors are not all prime. So you have to keep going. And that's what I mean by keep going until you can't go any further. So the factors of 20, and I'm going to go ahead and circle this too because it's prime. Anyway, the factors of 20 are 4 and 5. We already did that one. You keep going until you can't go any further. Square root of 4 here is 2. I'll circle it because it's prime. This is prime, so it's going to stay under the radical. So now what I need to do is I'm going to take this 2, and multiply them together, and I'm going to get 4, and that's going to give me 4 square root 5 as my final answer. You have to keep going here until you can't go any further, until either this number under the radical is prime or its factors are prime. Now, some of you might have learned this with a factor tree. Okay, prime factorization with a factor tree. This is the way I choose to do it. So if you know another way of doing this, that's fine. But this is how we simplify those radicals. You all, okay, and the people online will try this one. Everybody try this one on your own. Alex, how you doing? Are you on? Unmute your mic and say hi. Alex. Hi there. You have any questions? Okay. Kaylee, how you doing? I haven't seen you in a while. You there? Kaylee. Kaylee. Riley, are you there? Riley. Thank you, Kaylee. I saw that answer. Riley, are you there? Hi. Any questions? All right. Carson, are you doing okay? Carson. Okay, good. That's how I'll be checking, just so everybody knows if you're actually in the meet. Just randomly pick people and yell at them. Thanks, guys, for answering. All right. So this requires that we kind of know what the factors of 54 are. And if you remember your math facts, 9 times 6 is 54. So I know this can be broken down into 9 times 6. The square root of 9 is 3. And that leaves me 3 square root 6. Now here, I'm going to stop, even though this is an even number. And even though it's not prime, its factors are prime. Because the factors of 6 are 2 and 3, and there's nothing I can do with those. So this is the final answer for that one. Okay. So, sitting in class, what questions do you have? Now, I wish I could tell you there was a magical way to do bigger numbers. I'm going to do one more just to kind of give you an example. For instance,
what if we have like a 254? Just making it up.
All right, let's try.
Sorry,
let's try it. Let's see what happens. So 254. I don't know what the factors of all the factors of this are. So honestly, I'm going to grab a calculator because that's how I roll.
Okay.
And I want to see if I can take out a squared number first. So can you guys see? Probably can't see that very well. That didn't help. So I'm going to do 254 and let's divide it by 4 just to start. Okay, that's not going to work because it gave me a decimal. So right now I'm just looking for perfect squares. Okay, what if I take 254 divided by 9? Nope. And see, all this is, guys, understand what I'm doing here? This is nothing more than a guess and check. I'll do 254 divided by 16. Nope. 254 divided by 36. Nope. 254 divided by 64. Nope. So let's just say we keep going, and let's just say that there's nothing I can put into this. And even if I did 254 divided by 2, it takes me to 127, and that's prime. So in this case, and that's a good example. So in this case, I can't do anything else with this. Okay, I can't simplify this the way we're simplifying it. So I would leave my answer like this. Okay, but you have to check because I can give you this number. And if you say, well, I can't do anything else with that, I'm going to challenge it. Because I know 20 times 9 is 180. So you see, it's a guess and check. And that's what I mean. There's no magic way to do this. You just kind of have to guess and check. So the square root of 9 is 3. That leaves me with 20 under the radical. Okay. We know 20 can be simplified. That was the first problem I did. Factors are the square root of 4 times the square root of 5. And I'm going to circle this 3 right here because it's prime and I'm going to need it in a minute. Square root of 4 is 2. 5 is prime, so it stays under the radical. So then I've got a 3 and a 2. Multiply those together, and that gives me 6. Square root 5 is my final answer. So guys, on the bigger numbers, you're going to have to get that calculator out and just start putting numbers in and keep factoring it until you can't go any further. Okay? Now, I've only got 6 problems for you to practice. It's not like I bombarded you. Okay? So everybody on Canvas, I have 6 problems for you to do. Okay, I want you to try to do these. For those of you sitting in class right now, you can turn those in to me today. Okay, because it's 6 problems. You should be able to get them. So I'll take those from you today. Those of you at home, some of you have 2 assignments to bring to me. You have today's assignment that we've already graded, and you've got this assignment that we just did. If you are a remote learner and you get it done, take a picture of it and email it to me. Does anybody online have any questions? Okay, well, I'm going to keep you online just a little bit longer, so if you have questions, you can ask.
Okay.